whether the area is to the left or to the right or in the middle or we're shared with two tails, is your p-value that we test against your level of significance. Your level of significance is the maximum allowable error for type 1. So remember, we only do type 1. We do an alpha check, the level of significance. That's the only one we do. So the first part just says, let's look at your p-value and let's make a decision. You only make two decisions, one of two. Reject the null, fail to reject the null. Those are the only two statements you can make. We test the null all the time. The null is the one with the equal sign in it. It's the HO, and it has some kind of an equal sign, a less than or equal to, a greater than or equal to. Our sketch is the HA. That's where your p-value comes from. The shaded area from your HA. More? You said it all the way. All right. So, the first one says your p-value for a hypothesis test is 0.02337. What is your decision if your level of significance is 0.05? Now, on your sheet yesterday, I had you write p-value, the test for p-value. This is how we test your p-value. Keep it in this order, because if you switch the order and you don't switch the signs, it's wrong. So, take your p-value. This is your p-value right here. This is your area under your curve. This is your level of significance. So put your p-value here. Put your level of significance here. Easiest way to do this is fill this with zeros to match how many places your p-value is. So fill it with 4 zeros. Now, look at the numbers as if it doesn't have a decimal. It's 237 greater than or equal to or less than or equal to 500. Less than. It's a less than. So if you take a look at your page, page 347, if it's less than or equal to this guy, reject H0. You got to say H0 because you're going to have two hypotheses. You're going to have a null and you're going to have an alternative. So you got to say reject the null. If you just say reject, we don't know which one you're rejecting. So you got to say reject the null. This is the maximum allowable that we'll make. So in this case, we're going to say reject the null. Easiest way is fill it with zeros and make it match. If my level of significance is 0.01, here's my 0.01. Fill it with zeros. It's 237 less than or greater than 100. Greater than. So when it's greater than, my decision is fail to reject H0.
When you say accept, you accept H0.
Reject.
You're not rejecting.
No, but it's either you reject or you fail to reject.
Are you failing to them?
Yeah, we can't use any other words for this. We have to use the word reject in here. Either reject or fail to reject. It's kind of like, it's one of those things you have to just kind of follow the path. Did you follow that flow chart that I gave you guys yesterday to just look over last night?
Yeah.
It's kind of like the flow chart of when you decided if you were using a Z or a T. If it's less than or equal to 30, blah, blah, blah. Same kind of test for this. Test your p-val, see what statement to make. You have to use these can statements. And I am really, really fussy about these statements. You have to say these, fail to reject HO, reject HO. You have to put that in there. So you guys try it yourself at the bottom of page 347. I want your decision. Test your p-val against your level of significance. Remember, p-val, level of significance. If your p-val is less than or equal to your level of significance, reject H0. If your p-val is greater than your level of significance, fail to reject H0. Those are the only two decisions you can give me. Okay? So if this is your p-val, and this is your level of significance, fill this in with zeros, and look at the number. What's your decision on this one, on the first one? Fail to reject, because this is greater than, right? Good. Fail to reject what? HO. Good. So here's my p-val again. Fill it with zeros. Look at it like a number. So Monica, what's your decision on this one? Okay, so is 347 less than 500 or greater than 500? Less than. So follow your chart. When it's less than or equal to, what's the decision? Reject H0.
Yeah, why is it equal to?
One of them has to be equal to. So they picked this one. This is the maximum allowable one that we allow. So it could be equal to that as well.
Wait.
So one of them had to have the equal sign, and it's this guy.
How do you know which one's the equal sign? When
You have to memorize it.
When you reject it?
Well, the
Not
reject
when
has the equal sign. The reject has the equal sign. You can kind of almost remember it like this. When you do, like when you start getting used to these things, when you say reject and fail to reject, you're dealing with your HO. Your HO has the equal sign. So if you're using the reject one, make sure that one has the equal sign. I mean, there's just like little ways that you can remember it. But I will also give you that chart. I told you to write that on your chart from yesterday. I'll give you that, so I don't need you to necessarily memorize that. Now, we're going to see now where these p-values come from. Okay. Finding your p-values for your hypothesis test. For a left tail test, because we're working on your normal curve, the area is to the left. So the p-value that you find will be your area in the left tail. Makes sense, right? Same as we used to do with Z-scores. For a right tail test, it's the area in your right tail. How do we find the area in your right tail? Subtract from 1. Good. And for a two-tail test, it's the areas in both tails. So you're going to find your left tail. That's just your normal one. And you're going to multiply it by 2. Because you have 2 chances of getting this. The left tail, the right tail. You have 2 chances of hitting this. So let's see how these work. And if you want, I am on page 348 for those of you that just came in. Okay, find the p-value. This is the probability under your curve. This is the area under your curve. Just a fancy name. P-val, probability value. For a left tail test, here's my left tail. Here's my 0 of a z-score way out here of negative 2.23. I want to find this area. This area that I find is my p-val. Is my area under the curve. How do I find that area? Look it up. I go to my table. Table 4 is also in the front of your binder. The front of your book. Or if you have your table 4 separate. I think you probably like, probably a couple of these. So you look it up, and you find your area, remember, as soon as we look this one up, it is the area to the left. Go back to your normal curve. So your area should say 0.0129. This is your area in here. Can everybody find that? Go to your negative side. Go negative 2.3, come across to the 3. It should be this. We're building one step testing at a time. We looked at your p-val, now we're looking at how did you get that p-val? Then we're going to look at a z-score and incorporate that. We're going to incorporate one step at a time into this test. So here's your p-val, here's your level of significance. This is just what we did in the last example. They want your level of significance set at 0.01. See how it tells you in the problem what your level of significance is? You never have to come up with that one. 0.01. Easiest way, fill this with zeros to match the many places as this one. If this has 4 places, fill this with zeros. And then look at the numbers without the decimals. Is 129 greater than or less than or equal to 100? Greater than. So when it's greater than, what's our decision? Fail to reject, H0. Okay? So all we're doing now is that.
I don't know how you did that. I didn't have anything just the entire.
Well, the very beginning, the whole first part we did was just kind of explaining all the pieces. This unit, they kind of go into it a little bit weird this time. They start doing one step at a time, which in the long run is better because first you're testing your p-val and then you say, Lord, what the heck is my p-val? Oh, there's your p-val. The next step is using a z-score to get that z-score of negative 2.23. So we're going to incorporate this whole thing to make it make sense.
Yes.
Ladies, good? So everybody try it you too. Try it yourself too. I want you to come up with the area under your curve using your table, and I want you to test it against your level of significance. You're still a left-hand curve. It's right in the binder above. Yeah. First page.
Number one.
Okay, so you sketch this guy. You're looking for a left tail test. You're looking for it to be negative 1.62. Should that area be smaller or larger than the area that you found for negative 2.23? Larger. Good. It's covering more of your curve. So what is this p-val, this area under the curve? 0.0526. Everybody good with that? Okay, 0.0526. Now, take your p-val and compare it to your level of significance. Always set it up like this. It works so much easier. Here's your p-val. Here's your level of significance. Fill this with zeros. Now, is 526 smaller or larger than 500? Larger. Greater than. So what's your decision? Fail to reject what? HO. Gotta say HO. Because remember, we're going to have two hypotheses, an HO and an HA. Some books call it H1, H2. So it's really, really important that you say HL. Okay? Good so far? We're kind of bringing back what you did with your z-scores. You realize the next step is we're going to use a z-score and find the z-score ourselves.
Like these scores important.
Like we used to find all the time. Yes. So we're kind of incorporating all of this back into your hypothesis testing. Now, a two-tailed is slightly different. Find the p-val for a two-tailed test with a test statistic of 214. Now, here's your 0, here's your 2.14. But they said this is a two-tailed. Two-tailed means these tails have to be symmetric. So they can give you the negative or they can give you the positive because it's a two-tailed. So because, you're going to write it and take a 10 minutes. Because this is a two-tailed, we have a positive, we have a negative. So if they give you the negative, you know you also have a positive. If they give you the positive, you have the negative.
It's always symmetric.
Always, your curve is always symmetric. Symmetric about the mean. Now, you have two choices. You could look up the 214, but you're going to get all this area to the left, and then you have to subtract it from 1. Or, you could look up the negative and find this little piece out here, right? Isn't this little piece the same as this little piece? So that's why we say you have double the chance. So we're going to look up the area to the left, and we're going to multiply it by 2. I realize this rainy day is tough to get up here, guys, but come on. All right, so let's look up negative 2.14 on your table and tell me what you get. Good. These are both exactly the same. So in a two-tailed test, you're going to take the one of them and you're just going to multiply it by 2. 2 times the choice of the chance of getting it. Your probability doubles, doesn't it? Because that's why we multiply it by 2. Because you have a tail on the left and a tail on the right that has the same area that it covers. So we multiply it by 2. 12, 3. Think this is it? All right, so this is our chance then of getting this. All right, did I multiply this right? Close enough. All right, close enough today. 4, 12, 3, right?
Yeah.
Okay.
Let's
All right.
go.
But for some reason I keep looking at it. Maybe I'm standing too close. It looks a little strange. All right, so remember, it doesn't matter which statistic they give you for a two-tailed. You know your curve is symmetric. Go to the negative one, look it up in your table. If I looked at the positive one, remember it's going to give me my area to the left. I'm going to have to subtract it from 1 and then double it. So take as least amount of steps as possible. Okay, try yourself number 3. That's also a two-tailed test. Remember you have 2 equal tails. This is 2.31. This is negative 2.31. You're going to test your p-val to your level of significance. So what's the area on the left here? Okay? 0.0107. Everybody getting good with that?
10104.
How do you get that?
0.0104.
How do you get that? Oh, you went too far.
0.0104.
My bad.
You were very close. Okay? Now, that's the area in both tails. So you have twice the probability of hitting this now. You just increase your chances, they double. So therefore, double this guy. Times 2. Now, this is your p-val. Compare this p-val. Guys, come on. To 0.01. And 208, if you fill in your zeros and you just look at the number without the decimals, it's so much more helpful. 208 is greater than 100. So what is your decision? Fail to reject H0. Okay? Alright, so far, alright. Now, remember your z-score formula. Your z-score formula is x minus the mean over the standard deviation. This is when we deal with a population. When we deal with a sample, and the thing is, you're going to be using your sample to test your population. So we're dealing with your samples. We have to modify your standard deviation. We take your standard deviation, divide by the square root of how many are in your sample. There's no degrees of freedom in this. This is your z-score one. So we're just going to take your standard deviation and divide it by the square root of n. Because we always test a sample to make a judgment on your population, we're going to be using this modified z-score formula. Okay? And we're going to follow the same steps that we talked about following before, that we looked at in the regular part. We first identified your claim. Your claim is the most important. That you're going to state first. Once you state your claim, you're going to decide, is it your HO, your HA? Just like we did last week, in the beginning of this week. You find your level of significance. Your problem will tell you what your level of significance is. You determine your test statistics. You know, we just said they just gave us a z-score of 2.33 and it told us it was a double tail. We'll find that ourselves this time. We know which way, we have certain ways we have to go, and we'll find it. We find that z-score, and then we find its area. If it's a left tail test, it's the area to the left. If it's a right tail test, it's the 1 minus. If it's a 2 tail test, we take 1 tail and we multiply it by 2. We're putting all the steps together. We make a decision, and then we go to that little chart, and we interpret your decision. So you're going to kind of need those 2 charts handy. And I'll Xerox them again. I'll put them together, the p-val test and the decision, like how we make our decision. Because that, and I'm going to try to like put a couple of charts around here. I think that's really helpful, like when you can look up at them. So we're going to walk one all the way through. This is what you've been building up all week for. I'm sure you're so excited. Okay. On page 350. In an advertisement, a pizza shop claims that its mean delivery time is less than 30 minutes. So here's our claim. First step is we write the claim. What's the claim? How do I write it mathematically?
Means less than 30 minutes.
Mean less than 30 minutes. Remember, the symbol for your population mean is the mu sign. This is his claim. Is this the HO or the HA? HA, good. Now, write the HO. The mean is,
Less than 30 minutes.
okay, the statement you claimed was less, the complement of it greater than or equal to. Now, Guys, this is really, really important. Now you come along and you disagree with his statement about the population of his pizza shop. Every time you order a pizza, you know it takes more than 30 minutes. So you start sampling all the people that use his pizza shop. And here's your sample of 36 customers, and their sample mean time found to be this. So, with a standard deviation from your sample of 3.5 minutes, even though your mean looks like it's less, your standard deviation is what affects this. So, you want to know, is there enough evidence to support the claim? Notice the word support, because which one is your claim? HA is your claim, right? So remember the HA, the chart? HA uses the word support and failed to support, did not enough evidence to support. So all of this is going to tie in right now. So we say, okay, let us test this whole thing. So the first thing we do is we state the claim, HOHA. Now, we see what tail we have here. We go to the HA. The HA determines the tail. Which way is this pointing? Left. We have a left tail test. So somewhere, here's my mean of 30. Here's my 28.5 somewhere. I want to test this area under this curve against my level of significance. So therefore, I need a z-score. Now, in the last problem, they gave us our z-score. Now we're finding it. We're doing the whole thing by ourselves. So we're saying, take the mean minus the population mean over the standard deviation divided by the square root of n. And we're going to find our own z-score. So we take your sample mean, and should our z-score be a positive or a negative? Should be a negative. So therefore, our sample is smaller than our population, and that'll give us your negative. Your standard deviation divided by the square root of how many are in your sample. Remember doing this? We did all your z-scores. You kind of took a break during your confidence intervals. So these were our z-score weights. So we come out and we say, we have a z-score of negative 2.57. Ah, that's this little piece right here. So what's our next step? Good. Look it up in your table. So we're going to look it up in your table, and we're going to find this area, which becomes your p-val. So look up your area in your table for a negative 2.57.
0.00.
Good. 0.0051. This is your p-val. We did this all by ourselves this time. So now, our last step is to check your p-val against your level of significance. No, our second to last step. So our p-val is 0.0051. Our level of significance is 0.01. Fill it with zeros. Now, is 51 less than or equal to 100 or greater than 100? Less than or equal to. So what is your decision? Reject HO. Now, follow your chart. Get your chart out. Your claim is your HA. If you reject HO, walk through this with me 1 second. If you reject this, then you're going to take this one, right? So you're supporting. Now you can follow your chart. Your claim is your HA. You reject HO. So you have enough evidence to support the claim that the delivery time is less than 30 minutes. That's your interpretation. Even though we use your chart, I want you to think about it as, is this one good or is this one good? So if I reject this, that means I take this. And if they're using an HA, I have to use the word support instead of reject. The answer is, our final decision is, there is enough evidence to support the claim that the mean delivery time is less than 30 minutes. Your test sample showed that he was right. His mean delivery time is less than 30 minutes. Now, who do you think made this claim? The pizza place. What makes you say that? Well, they want their deliveries in less time, which is saying this is why they're saying less than 30 minutes because they want it.
I want the claim to be supported.
And you want the claim to be supported. If this is their claim that it's less than 30 minutes, yeah, they want to support this claim. If you're going to reject it, you're the challenger. Okay? So you're supporting this, and yes, he wants his delivery time less. He certainly doesn't want to say my delivery time is more than 30 minutes. So your delivery time is less. Okay? Does everybody see what we just did? We walked the whole thing through. All the stuff that we did the past 3 or 4 days is right here. So let's do another one together. Okay? Guys, this is really, really, really important. Last one and we'll call it a day. All right. Homeowners claim, oops, here's my claim. This is how you take this apart. There's the mean, there's the claim. That the mean speed, these are the homeowners, they claim the mean speed of automobiles traveling on their street is greater than the speed limit of 35 miles an hour. I'm a homeowner. These people speed past my house all the time. So I claim that it is greater than, they are going more than the 35 mile an hour speed limit. This is my claim. Is this the HA or the HO? HA, good. What's the HO? Less than or equal to. Okay, I'm a homeowner and I am claiming that the speeds are over 35 miles an hour.
Why is that CHA?
Because it has no equal sign. HA has no equal sign, HO does. Now, in a random sample, here's my sample, pull this out. Sample of 100 has a sample mean of 36 and a standard deviation of 4 miles an hour. Here's my level of significance, 0.05. Is there enough evidence to support this claim? Now let's check. Support means my claim should be which one? HA. So is my claim HA? Now, my tail test goes on the arrow of my HA. Which way is the arrow pointing? To the right. Here's my mean of 35. Here's me of 36, my sample, and I want to the right. Is my z-score going to be positive or negative? Positive. So let's find your z-score. We've got a sample, so we have to take that into account with our standard deviation, because you're always looking at your sample when you're testing against the population. If you knew everything about the population, you wouldn't have to test it. So we take the mean, your sample mean, minus your population mean, over your standard deviation, divided by the square root of 100. This is your z-score. It's got to be positive. 2.5. Okay? Which makes sense, right? Now, I need to find my p-val. I need to be able to test my p-val against my level of significance. I know my level of significance, but I need to find my p-val. How do I find my p-val for a right-hand test? Okay, I look it up in the table and I subtract my area from 1. Very good. So I look this up. I find what this says on my table, 2.5. So 2.5 says 0.9938 And when you look at this, is it possible then less than half the curve has 99%? No. So therefore that also tells me, oops, I was supposed to subtract this from 1. Because look at how large this is here. There's only going to be a little sketch of that area here. So subtract it from 1, and you get 0.0062. This is your p-val. This, almost guys, is what you compare to this one. Fill this with zeros. Is 62 less than 500 or greater than 500? So you've got a less than or equal to. What's your decision? Good. Eject H out. One more.
There is not
To support the claim that the speed is greater than 35 miles an hour. Ta-da!
Yeah.
Yeah, you get